when you're comparing these industrial scale solar plants, which can cover hundreds and sometimes thousands of acres, versus a windmill that the whole field of windmills can also occupy a similar, even a greater amount, one of the things to recognize is that there is habitat here, and we're seeing lizards moving in and amongst the windmills. I'm sure there's kangaroo rats and pocket mice, and so there's a lot of stuff that is left intact, and so the habitat is still functioning and still working here, as opposed to, again, those the industrial scale solar, not the rooftop solar, but the industrial scale solar, and that really tends to destroy the habitat, whereas this allows the habitat to stay intact. For the second stop of our tour of renewable energy, we visited Palm Springs Windmill Tours to understand the past and future of wind energy. We're here with Randy Buckmeister, who is the manager of the windmill tours here, and we're going to chat about windmills and green energy and what role they play here in the Coachella Valley. So, Randy, I've lived here since the mid-1980s, and I've seen the fields of windmills evolve over the years quite a bit. They used to be much smaller and lots of them, and now they're much fewer and really, really big. So could you just give us an idea of how that evolution has happened over time?
Sure, you're right. Like the ones you see back here are, anywhere from 20 kilowatts to 200 kilowatts. Where today, the largest ones we have are 3 megawatts. So it's been quite an evolution. The smaller they are, the closer they can be together, as you saw all those years. As those have come out, they've been replaced by these larger ones, and they need a much greater distance between them. So that one doesn't interfere with that one. So, and as they grow bigger, that number grows higher. And so what's happened here, we've gone from over 5,000-6,000 wind turbines at one time to, we're probably down to, I'd say right now, 1,700-1,800. It's a hard number to pin down.
Sure.
We're going to go down below 1,000 in this area. You're going to see even more clearing out of some of these older ones across the highway. They look more modern, but they're still getting old. So we're going to see a continual fluctuation of smaller numbers, but we're going to see bigger machines, and they're going to produce so much more, and so there's really exciting. This has become another exciting place again, like it was 40 years ago.
Right. You're talking about kilowatts and now megawatts. And I think for a lot of us, we know megawatts are bigger than kilowatts, but it's hard to make that conversion. I know one of the questions that I often get is, how much energy does the entire field of turbines produce, and make that an equivalent to like the energy needs of Palm Springs or the energy needs of the Coachella Valley? Is it 20%, or is it 50%, or is it 10%? What are we talking about there?
At one time, the State Wind Energy Association proclaimed we were the third largest in California, and we had about 670 megawatts of energy. I'm told that's plenty to power the valley if everything's working at one time.
So when the wind is blowing.
So when the wind's blowing, it is enough to power the valley. But obviously that doesn't always happen. But when it is, and we are one of the windiest places in the country, if not the windiest, so we get a lot of wind. This happens to be a dead time of year. Because we're cooler, and our heat, our wind is heat driven, solar driven. For example, one of these, it's 1.5 megawatts or 1,500 kilowatts. That's enough to power approximately 500 to 600 homes.
Okay, good. That's a good equivalence.
The big Vestas that we have down here, the largest ones we currently have, are 3 megawatts or 3,000 kilowatts. They'll obviously then produce about enough for us anywhere from 1,000 to 1,500 homes. It's pretty easy flip over. 1,000 kilowatts
Is a megawatt.
is a megawatt. So, and then of course we have gigawatts, and now we're hearing about nanowatts. As things increase.
So is that 1,000 kilowatts?
Yeah.
Megawatt?
Yeah.
Yeah. Okay, got it.
The machines here are currently 1.5 megawatts or 1,500 kilowatts. The largest ones we have currently are 3 megawatts or 3,000 kilowatts. That's going to be enough to power about 1,000 to up to 1,500 homes, average homes. In Europe, that would be a larger number because they don't use as much electricity as we do here in the U.S. And of course, 1,000 kilowatts is a megawatt. And so we're easily seeing them. They're putting them up on land now that'll produce almost 6 megawatts.
So there's a couple of questions that I hear from the public, and you can address these. One of which is, so we have these windmills here in the valley, and they're creating all this energy here in the valley. Does the energy stay here in the valley? Is it here for the residents of the Coachella Valley, or is it dispersed throughout the grid?
Well, electricity's interesting. You can't tell the electrons apart between what the wind makes and what solar makes or whatever. And then the way the grid system works, we have a big substation up here. It's the largest one in the area. It's called the Devers substation. And that's kind of the mixing spot for all the power sources we have here, including power from nuclear generators coming in from Arizona. They all come in here, then it's distributed. I like to think of that substation kind of like a punch bowl. In a punch bowl, you take 7-Up and you take whatever, you take all your ingredients, you pour it in. When you take them out, it's all together. That's kind of that substation. All these ingredients go in and one product comes out.
Basically electrons.
Yes. Yeah.
One of the issues, again, I've been here since the mid-1980s, and I've heard there are people that love the windmills and people that hate the windmills. And I remember hearing these just bizarre stories like the windmills are really just here to blow the smog back to Los Angeles. I don't know if you've heard that story before.
Yeah.
But other people just are arguing, they're just so ugly, and why do we have them here in this otherwise beautiful place? My own personal feeling is we need energy, and we could have a coal-fired plant that is, belching smoke and terrible things, or we can have windmills. And personally, I'd rather have windmills. But have you? I guess asking you, the public perception of the windmills, is it becoming more positive or staying mixed, or how do you think that's working?
Oh, I think it's become much more positive. Because over the years, people have come to just find their landmark, if nothing else. You leave LA and the traffic, and you get up here to the hill, and you come down, you see windmills, and you're going, I'm home. I can drive again. But it is amazing to me when I wear my logo shirt around. I was at a Walgreens not too long ago, and a lady saw my shirt, and she said, well, where does all that electricity go? We don't get any of it, right? And I hear that a lot, and like I said a little second ago, that's just not the case. It all feeds in. We get a part of it. Do we make enough here to power the whole valley? That's what I'm told. Can we say that's all the power we get is the windmills? No, we can't, because that's not the way the system works.
Right. The other concerns about the windmills, and maybe you can address this, and I don't know if there's really a way to address it, but these turbines are, when they're going, they potentially are risk for things like birds and bats and so forth and so on. And I was wondering, when we had, an order of magnitude more little ones, and now we have fewer big ones, has that changed that at all, or is there a way that technology is working forward to reduce the impact on migrating birds and things like that?
Well, first of all, the bird thing is blown way out of proportion.
Okay.
Such as here in the San Gorgonio Pass area where we stand. In this wind park, we've never had any large predator birds hurt. None. Zero. I've never seen a dead bird out here, and I've been out here 6 years, and I've been here on all kinds of weather. Nationally, only 0.1% of all birds killed by man-made objects is killed by wind. So it's a relatively minuscule number. And the wind energy does take it serious. There are places where there's eagles in residence. They've come up with eagle radar. And there's eagle radar out there where they can spot eagles in the area and change the speed of the machines so that the eagles are safe. But what they have really found, and I've been reading about this lately, birds are a lot smarter than we think they are. And they just stay away from them. They avoid them. And so that's a problem that's been obviously put forth at the highest tiers of government, and they're just simply not true.
Okay, good. At this point, we're still doing this conversion to larger and larger machines, larger windmills, and each of the, as large as they get, we're increasing the power outage of each one of them. What is your vision for 5 years, 10 years, or even 20 years from now in terms of how the windmills are going to look in this pass area or in the Coachella Valley?
Well, as this changeover occurs, we're going to become more like Sonoma County, where they have all, at this time, currently pretty modern machines. They have far less machines there than we do here, but they produce like right at a gigawatt, almost 1,000 megawatts of power. They produce a lot more power than we do. And that's what's going to happen here. We're going to have probably 700 or 800 machines, but we're going to produce a lot more power, and it's going to be a lot more efficient because the machines only get better as they develop them, and the machines have continued to improve and much more reliable.
Okay. So what you just said made me think of another question. When the windmills were first established here, again, this was probably in the early 80s, it was in the Jimmy Carter era. My understanding was that the United States didn't have a lot of wind technology, and so we were borrowing it from basically the Dutch and having their technology guide us on how we move forward. And they're still probably one of the leaders in the world in terms of wind technology. But today, you mentioned that these are General Electric owned, these are Mitsubishi, and so where are these windmills being produced? Are they being produced here in the US, or are we shipping them in from someplace else? Where are we getting them from?
A little bit of both, but there's over 500 factories in the US affecting all 50 states that currently affects the wind energy business. Vestas is a Danish company, and Denmark has been a real leader. And they have 4 factories up in Colorado, and they produce full wind turbines in Colorado. It's cheaper to ship them. You don't have to put them on an ocean liner. And so you can make them up there in Colorado and then put them on the interstates, and it's much more economical. And so there was an old submarine factory up in Wisconsin that was turned into a tower manufacturer. They're all over the country. There's an old appliance plant in Iowa that now makes wind turbine parts. So there's over, well, it's hard to tell right now because of what the virus has done, but there was over 100,000 jobs in wind, and that number was set to grow. And I think it will continue because the wind industry hadn't stopped because of the coronavirus. It has continued to move forward.
Next, Randy explained how wind energy is converted into electric power.
It actually is quite simple. All the different wind turbines have their own wind stations. They take about 7 to 10 miles an hour of wind to start themselves up. Nothing else starts them but the wind. Now, the blades are variable pitch, but the blades are also the brakes. And as you look around us here right now, we don't have a lot of wind. Virtually all the blades are in the braking position. They're going to be like this to the wind. But when that machine detects enough wind and it's pointed in the right direction, it's going to turn that blade. And that blade's going to be like an aircraft wing. It's going to create lift. And that's what makes it turn. Well, that turns on most of the ones we have here. It turns a large shaft that goes into a gearbox. And inside that gearbox, there's really dramatic gear ratio changes happening. And then another shaft comes out the backside, and that's what spins the generator and makes electricity. So it's totally pollution-free. It's driven by the wind, and electricity is produced by the wind. This is the gearbox out of one of the original Danish machines we have here, 65 kilowatts. The blades would be attached over here. There'd be another shaft come out the backside that ran the generator. This was actually a brake disc because in the old days they didn't have the variable pitch blades, so they used brakes to control speed because the old generators required one consistent speed. So the idea by looking at this is you're going to get an idea of how that gearbox works. As you can see, I'm not moving it very fast over here. And all down inside here, there's all different ratios of gears. And that's how the wind builds the power to turn that generator.
So it's basically taking wind energy, converting it to mechanical energy, then converting that to electrical energy.
The electricity is produced. It comes down the tower. These GEs produce 690 volts, three-phase AC. It comes down the tower through cables. There's a green box sitting at the base. It's a step-up transformer. That step-up transformer is designed to increase the voltage from 690 to 34,500 volts. It then goes underground. All of our energy is moved underground to small substations that is dotted all over the desert. Those substations then bring all that electricity together, and then it goes underground again, and eventually ends up to big Devers. Now, there's a reason they keep stepping the voltage up higher. They want the higher voltage because you're going to have less loss during transfer, and you can use smaller cables. So it's more economical to step the energy up. Some of our lines going out here are 500,000 volts. So the energy continues to be stepped up in numbers. Okay, first of all, the two cheapest sources of power we have available in most parts of the U.S. today is wind and solar power, commercial solar. They're the two cheapest forms. they're going for pennies on the kilowatt. And in some cases, some of the new facilities they're building, like in Texas, do include batteries. So the renewable energy industry has really learned to meet the needs of everybody. If we had the full backing of the government right now, like we did previously, it could probably be much better even than it is today. But right now, that's a little iffy. So it makes projects a little harder to go forward. But it is still happening. Regardless of everything, new projects are moving forward. Some people will tell you, but it's so dirty, the manufacturing process, the transportation, getting them out to the field. It's just such a huge carbon footprint. That's not true. The manufacturing process, yeah, there's going to be some issues. But overall, the carbon footprint is paid back by one of these. From all the studies I've seen, will tell you the carbon footprint is paid back in less than a year.
That's a really good piece of information, because I remember having people who I thought knew what they were talking about. Again, this goes back to the old windmills back in the 1980s, but they would say that they never pay themselves off because they're just not producing enough energy to compensate for the shipping and the manufacturing and all of that sort of thing. But what you're saying is within a year, and maybe for these big ones it's even less than a year, you are, from that point on, it's all green energy.
Yeah, exactly. So it is really, truly one of the cleanest forms of energy. I mean, there's no pollution coming out of these machines. The closest thing we have to pollution is what some people would call visual, and that's when the shadows fall on the ground. So you have to be really careful where you build them. You don't want to build these right next to a home. You need a distance. You don't want them up close. Not that they're going to make a ton of noise, but that shadow does produce. If you're sitting in your living room and that blade's going across your living room window, that shadow, it's going to drive you insane. So you don't want that too close. But that's not a physical pollution. And I know one of your questions earlier had been, what are the environmental issues? Well, people ask me that, and I got to tell you, I can't find any. Birds are not the issue that they claim they are. They don't cause cancer because of the noise. And if you're out here when they're turning, they're not that noisy. At a length of 100 meters, it's the same as a home refrigerator. So we live with that every day.
Yeah.
Even up close, the decibels are relatively small.
Sometimes we'll be driving around through this area and it's really windy, and only about half of the windmills or some portion of the windmills are blowing at any given time. The rest seem to be not working. Is that because there's so much energy being produced you can't add it to the system, or is it really a decision based on economics that you're looking at who's buying the energy and whether the price is right at that point?
Well, there's actually 5 answers to that. In most places, you'd only have 4. But here, until recently, and we still have older machines, sometimes they're just tired. They don't work. They've removed many of those. They're gone from the landscape. So that kind of gets rid of that reason to mostly. One, they need 7 to 10 miles an hour wind. Now, we may think that wind is consistent, but I can tell you right now, you can have gust over there and have nothing over here. You can have that machine and that machine, one of them set right next to each other, and one has enough wind and the other one doesn't. So wind is not kind of like I think many of us have in our brain, this consistent wave. It's an flows. So sometimes there's just not enough wind for all the machines. Most of the time here we have plenty for everything. Now there can be too much wind. Most of these machines are designed by 55 or 60 miles an hour to shut themselves off. They go into self-protection mode. They turn the blade to the braking position. They stop. And they wait until the wind drops below 50, and then they turn themselves back on. So they could be stopped because there's too much wind. Like this week, Monday, we had a big shaft out here that we had up for a Wi-Fi system. It couldn't take the wind. So there can be too much wind. There's days like that when you come out here and we don't stop our tours because of wind. And Mother Nature gives you a free microdermabrasion out here in the desert because the sand really blows. Now, it could be they're just down for a maintenance issue. Some of the technicians out here will tell you the machines are very, very efficient. They don't break a lot, but they are machines. They are man-made and they do break. So that happens. Now, currently, sometimes there is just too much energy for the system. And the grid operator, Cal ISO in our case, can tell a block of these machines to shut down for some period of time. So you'll see on a really nice windy day, perfectly good machines standing there doing nothing. And that's because we don't have storage. We don't have ways to store that extra electricity. As that comes along, that will clear that problem up. But currently, there's just not enough storage, and so somebody has to quit producing. Now, I understand that WindTech is involved in a project that will probably include a large storage facility over here where there used to be windmills. But that's the future. This natural gas plant we have up here, the Sentinel, is an 800 megawatt natural gas plant. And it's the cleanest form of fossil fuels is natural gas. But yet you read here in the Coachella Valley, that's still, even though it doesn't run nearly all the time, it's still the second biggest polluter when it does run. Even though you can't see it, it's not like a coal plant. All you see is heat waves coming out of it. There is still gases that are detrimental. So they try not to use that if they don't have to. So if you can store it in batteries, and then the question becomes, what's the most efficient battery? Lithium ion is obviously the battery of choice today, and that's what most of storage is. But there's a feeling that long term, that's not going to be it. There's going to be other much more innovative forms of storage. But I'm told that we are getting a storage facility here. It's going to be quite large. And so what that does, it stabilizes the grid. During the day, sometimes you don't use as much power during the day, but we've got solar. We have lots of solar. During the evenings, we often have wind. Well, if there's excess of that, currently they either have to shut a machine off or give the electricity away. So if you can store that excess electricity, which is what we're learning to do, Southern California Edison is constantly adding storage. As we learn to store it, then when the solar goes away, like right now about 4 o'clock, as people get home from work and turn their lights on, they can tap those battery storage units for additional power, and they don't need to use other sources then. So it's a very efficient way. Down in Australia, South Australia, they had a terrible grid problem. Tesla went down there and put in a large storage facility right next to some wind turbines. And immediately, this was like almost 2 years ago, immediately that thing could kick in, and it kept them from going offline, which they were doing all the time. So storage will have a real effect, and California is moving in that direction, but a little slow moving sometimes. In fact, you can get a app on your phone from the ISO, and it will tell you what sources of renewable energy are being used at the time, and you can see the fluctuations, and anybody can get it. So that's kind of interesting to watch.
And so are they the ISO, and I'm not sure, is that a federal or a state, or what is that?
It's a quasi-governmental thing. It's a independent system operator.
Right, so there should be independent. So I guess my question then becomes, if there's too much energy coming in and they have to make choices as to which they would take, personally I would say get all the green energy and let the fossil fuels go by the wayside, but the fossil fuel folks might be pressuring them on from a different side, saying no, use us, and then when we're not enough, use the green energy. Is that kind of equation in there or not?
If you look at SCE, they will tell you they get very little of their energy from coal today, because there's no coal plants, as I understand it, in the state of California left. It all comes from out of state.
Right.
But oftentimes it comes to SCE mixed, like we talked about, and you don't exactly know what's what. But yes, it's hard to, you don't just tell a coal plant to spool up, spool down at the drop of a hat. That natural gas plant up there is a peaker plant, and it's made to run. That whole plant produces 800 megawatts of energy, a lot. And it could be up and running from a dead stop in less than 10 minutes. So it's very nimble on its feet, but you can also shut it down just as quickly because it's run by turbine engines. A lot of it has to do with, you just don't turn a nuclear reactor off, you know. We don't have a lot of those left either, except that we do get ours from
Palo Verde out there.
Yeah, Palo Verde in Arizona. I understand we get one generator from them. One of the units comes to Southern Cal or to SoCal.
So I was just wondering, like the current governor, Gavin Newsom, has said that we're going to buy, I think it's 30% renewable energy by 2030. I think that's his number. I'm not exactly. But so if the California ISO is paying attention to that, they should be emphasizing the green stuff and only adding the fossil fuels or the nuclear when they have to.
I think they do. You know, down in Texas, they had really fought it to some extent, but they're the largest wind producer in the U.S. by far, and they've learned to. They've run their system with well over 50 to 60% of electricity coming from renewables. They never thought they could do that, but they've learned how to make that happen, how to make it work. It's very doable. Everybody just has to put their head to it, and I think the ISO does do that.
So we're looking at the design of the blades themselves, and it almost looks like a bird wing, or as if it's biomimicry. So when you see that shape, especially that little uplift at the end, how does that affect the efficiency of how it collects wind?
Well, there is a certain amount of, kind of like on an aircraft, there's a certain amount of wingtip vortices, some turbulence that comes off the end of that blade. And so in order to reduce that, GE has added that little crook, and that's been their way of doing it on these machines. Now, if you go down here to the big Vestas, if you're down there by them when the wind's really blowing, it's really cool. They don't have that. But what you see is the blade, the harder the wind blows, the blade begins to curve back. And it's a real beautiful curvature. I mean, it looks really elegant as those blades go around. And that's their way of reducing that, by bending that blade tip away from the wind. So all the different companies have found different ways to reduce that turbulence.
That's interesting, and it reminds me of a hummingbird wing and how hummingbirds can adjust the direction of their wings and the wing tips to go forward or backward or up or down. And so the engineers may have figured out, but I think hummingbirds and other birds might have figured it out first.
Even from here, that looks big, but you get over there underneath it, it's big.
Yeah,
really big.
It is pretty amazing. I have, I think they're some of the largest ones, but they're over there by Willow Hole. There's about 5 or 6 towers that are enormous. And I've watched the workers have lunch on the top. They just sit on the top and they look like little ants on the top there.
Those are 80-meter towers over there, 262 feet. And those are 2.5 megawatts, made by a U.S. company at the time called Clipper, I believe. They were called Clippers. They have a real different system to them than any of the machines we have over here. Now, the interesting thing about those, they're over on Edom Hill. They don't get nearly the consistent wind that we get over here.
I was going to ask you about that because I can see these turning almost every day. There's some of them, if not all of them, turning. But when I go over there, because we do some work nearby, they rarely turn. And is it efficient or economically efficient for them to be put in there?
You know, I'm not sure. They normally measure all that ahead of time, so they have a good idea whether it's going to pay off or not. But you're right, I see that too. I watch them. But you know, our wind here is produced by the San Gorgonio Pass. It's the only pass for about 100 miles in either direction. It's one of the deepest passes of the country. It's only 2,600 feet up to Banning and Beaumont. Now, you almost always have cooler weather on their side of the hill. We're a desert. We get very, very hot, as we did this summer. And right now, we're going to be pretty warm. As the desert heats up, the air gets lighter and it gets pushed up into that pass. And then the air to the west of us is often cooler, heavier. It gets sucked in underneath that hot air. It causes a natural Venturi effect right here through the pass. As the pass opens up, that begins to settle down. Down here at Indian Canyon seems to be about the extent of the really good wind. Then it becomes a little less consistent. But the reason we have some of the best wind in the country is because of that pass. It's solar generated.
So the way we're thinking about this is the heat from the sun is what generates the wind. And so what we're really doing is going from solar energy to wind energy to mechanical energy to electrical energy, and that's what feeds our houses. And that's pretty amazing.